Okie dokie, we are on day 2 of graphs of polar equations. We're checking for symmetry and we're classifying them as well. So here's the thing about the symmetry. And we did tests for symmetry. We did algebraic tests of symmetry back in 1650 when we were working on functions and things like that. So there's an algebraic way to do this in polar equations as well. However, here's the thing. This down here, oh, oops, sorry, I should probably switch to a different color. This stuff down here tells you algebraically how you would do this. The problem is, if your equation, if it passes the algebraic test, then there is definitely symmetry. But if it fails, oh gosh, what are you doing, dude? Okay. Okay. If it fails your algebraic test, that doesn't necessarily equal not symmetric. That's the problem. You can do the algebraic test and it can fail the algebraic test, but it could still have symmetry. So like for me, for us, especially because we are now in a obviously new kind of format for this, we're not going to do the algebraic test. There's no point in doing it. So we are going to do visual tests for the 3 axes in the 2 axes in the origin, I should say. So your polar axis is basically what you would think of as your x-axis. The line theta equals, whoopsies, so off of there, theta equals pi over 2 is what you would think of as your y-axis. And then the pole is what you would think of as your origin. Okay, and so when we go to check symmetry, we'll talk about that when we get there. These are your types of polar equations. So you have a lemniscate, which is Latin, like it comes from the Latin for meaning a ribbon. I always think it looks like an infinity symbol. You have 2 types of rose curves where you have the n is even. So like the number in front of the theta would be an even number, and you have where the n is odd, where it would be an odd number. You have Archimedes spiral, you have a circle, and then you have what are known as limacons. It's a French word with a Latin base. It basically means snail. So you have a one loop, an inner loop, and a cardioid. The cardioid is a special case of limacon where you actually have where the numbers here, like you would have like 5 plus 5 cosine theta. Well, 5 over 5, I'm just making up a number, obviously, that reduces down to 1. So when you look at that, if you have the equation in front of you, if the a and the b, if the 2 numbers are the same, then it's going to reduce down to 1. That's your special case of a limacon. Okay? Really, honestly, if you don't have the equation in front of you, you can't really tell the difference between a cardioid and a one-loop limacon. All right, we are going to identify the types of symmetry and classify the graph. First thing that we're going to do is classify it just because we can get that done and out of the way. It is obviously an odd numbered rows, right? So it is a rows. Okay, so that's the type. And then what we're gonna do, here's the thing, when I always, you're gonna hear me say hamburger and hot dog. So here is your polar axis, right? If you can take your graph, so like literally, your 3 petals, basically, if you can take and fold it hamburger style, meaning top down to bottom, right? If you fold it hamburger style and the top part sits directly on the bottom part, then it definitely has polar axis symmetry, okay? So this has polar axis symmetry, okay? Then you check for the line theta equals pi over 2. So basically, oh gosh, terrible. Basically your y-axis, and you would fold it hot dog style. So basically if I take and I fold the right half over to the left half, As long as they sit down, they sit back on each other, then we'd be okay. The problem with this is if I fold right over to the left, what I end up having is a very badly drawn petal, but this petal right here folds over and it sits down there. And so obviously then I have 3 petals on the left side of my graph. So that does not have, and I'm going to write it just so it's there, theta equals pi over 2. It is not symmetric with respect to that. Okay. And then the third type is about the pole. So basically what ends up happening is if I can take my shape, and it's tough to do this over an iPad, but if I can take my shape and pick it up and rotate it 180 degrees. So basically what I do is if we were in class, you would see me do this. Basically what I would do is I would put like a finger there and my thumb over there. So I'm kind of like pinching, I'm pinching the graph basically. And it's weird guys, because I'm actually doing this right now while I'm sitting on my couch in my living room. I would actually pick up my hand and rotate it 180 degrees. So basically my finger would be back over here and my thumb would be back over here. And so I'm like imagining I'm picking up the shape. And obviously if I pick up the shape and rotate it 180 degrees, it does not sit back down on itself or back in the original position. So it does not have symmetry with respect to the pole. Okay. All right. So this one, when we classify it, is a limacon. I try to make that shape on the C, and I don't know what it is. It's in French. So if you have French, then you know what it is. Technically it is an inner loop. Okay. And those you can tell exactly what they are because they've actually got that going on. And then here's the only symmetry that it has. I'm not going to walk through all 3 of them. The only symmetry that it actually is going to have is symmetry with respect to the line theta equals pi over 2. Because I can fold it hot dog style, and it sits back to, like, the right part sits back down on the left part. Okay? All right, classifying this guy. This is a lemniscate. See if I can remember how to spell that. There we go. It does not have, I think I did. That's right. It does not have symmetry with respect to the polar axis. It does not have symmetry with respect to the line theta equals pi over 2. Because again, polar axis would be hamburger, right? And if I fold the top down on if I just try to fold the top of the graph down on the bottom of the graph, it's not going to sit back down on itself. And if I take and try to fold the right side of the graph over to the left side of the graph, meaning hot dog style, it's not going to sit down on it. It's not going to match up basically. But if I put, my pointer finger here and my thumb here, and I pick that up and rotate my wrist around, and yes, I am a complete dork because I did it again. I actually did the whole hand motion thing. If you sit it back down on itself 180 degrees, it actually does have symmetry with respect to the pole. Alrighty. This last one is a limacon again. Oops. Ugh. I can't write that thing. And again, if it's an inner loop, we can classify it as an inner loop, but we don't have an equation in front of us. So we don't know if our A and our B, like our number and a number in front of the trig, are the same thing. So we can't do that. And the only symmetry that we have, is with respect to the polar axis. We got nothing else because we can fold it hamburger style and it sits back down on itself. But we can't do hot dog, and we can't rotate it around 180 degrees.